Okay, so we're going to make a game here using our Arduino, and our first step is to build a circuit. So all we need to build our game is we're just going to be a little reaction game. We'll expand on it too, but we're going to have a little LED here. We're going to have connected to pin 12, or you can connect it to a different one, and it's got the resistor pulling it to ground. And then we have a button here connected to one of the digital pins as well, and it's going to connect to ground too on the other side. And so before we can build our game, though, we just want to test and make sure that our circuit works. So we're going to write some code to go with it just to test it out and see everything's working as expected. Okay, so the way we're going to do this is we've got our kind of starter code here, and we're going to set some variables. So we'll set one for the LED. So LED pin is going to be 12, and the button pin is going to be on 7, and we can easily change those later. And so we'll say pin mode, and we'll set button pin. Actually, we'll do the LED pin first. We're going to set the LED pin to be an output. And then for the button, we haven't really learned about the buttons yet, but we're going to set that button to be we haven't learned about inputs yet, but we're going to set that button to be an input, and that's a way that we can pull data in, and we'll learn more about that later. And not just an input, but we're going to call it an input pull-up. Here's the reason why. When we press that button, we're reading what the voltage is, and if it's not pressed, it needs to pull. It's going to pull up to high, and so it's going to read as high when we're not pressing it, and when it is pressed, it's going to read as low because it's connected to ground here. If we just do an input instead of the pull-up, when we don't press the button, it doesn't know whether it's supposed to be high or low, and it doesn't have a way to switch states, and so it will behave in a way that is unpredictable. And we'll learn more about that later. Okay, so we got our input, and now what we'll do is we're going to just read it. And so to read that input, we're going to say digital read, and then we'll read that button pin. Okay, and so this is a function. Let's change it here to button pin. This is a function that actually reads whether the button is pressed, and so it could be helpful to print it out and see that it works. So serial.print or serial.begin 9600. All right, and then here we're going to actually print this out, and so we'll say serial.print ln, and then we got in parentheses. Okay, then we'll add a short delay, and so here we can see that our button is working, and we're getting an input from it. So I'm going to start the simulation here. You can run your code on your device, and then we'll pull up the serial monitor, and we can see here that's showing 1, and then when the button's pressed, it switches to 0. Okay, and so we're getting that button press registered. And so this is kind of our first step to make sure that our button's wired correctly. And so if you're pressing the button and it's not registering here, you want to first double check that you ran the code on the device. Make sure that you've got the button connected to the same pin that you have here. Make sure the legs are connected on either side. Because if it's not working, probably there's an issue with the wiring or with the code they've written here. Okay, from here, we're going to also test that LED. And so we're going to add another line here that says digital write. And then we're going to say not digital read button pin. Oh, we got to tell it to, it's the LED. So LED pin. And then what this line is going to do, it's going to set the state of the LED to be the opposite state of the button. And so remember, the button reads high when it's not pressed and low when it's pressed. And so we're going to do the opposite with the LED. And what this will do is this will turn the LED on when that button is pressed. And you can see our LED going on. And so here we verified that all of our wiring is correct, and this is doing what we expect it to. Okay, so this is our important first step. Now that we know that everything's working, we can proceed to start the game. Okay, so the game, it's going to be like a it's going to be a game where we use some type of like measure like reaction time, and we'll modify it later to be like a 2-player game. But basically, what we're going to do is we're going to set our LED to high. So digital write, LED pin, and we're going to set it to high. So we're going to turn that LED on. We're going to delay some amount of time, and then we're going to turn it off. So digital write, LED pin, low. Okay, and then once this is done, we're going to wait. So this is a while loop, and this is something we haven't learned about, but we're going to use this to wait until the button is pressed. So we're going to say while not digital read button pin, and then we'll have just a serial dot print ln button pressed. Okay, and so this is kind of the start of our game. We're going to modify this to be a little bit more exciting and to do some other things, but this is the basics of it. So we're going to turn the LED on. It's going to turn back off. Let's turn it on for 2 seconds. So 2000 here. We'll turn it off, and then we're going to wait for the button to be pressed. And when it's pressed, it's going to print this line. And so what this line does is it's going to basically execute, and a while loop maybe normally looks like this. You'll have some opening and closing brackets, and it can do something in between, but we don't really need it to do something. We just want it to wait, and that's why we have this. And that's why we have the semicolon here, which means that there's no block of code to execute. It's just going to keep checking the button until it's pressed. And there's better ways to do this, but for our purposes, this is going to be fine. Okay, and then when we press the button, it's going to register that. And then maybe we wait again for a little bit, another second, and then we start the game over. Okay, so we're going to run the simulation. And so our LED is on, it goes off. Oh, and it did register the button press. So let's think about this. So our logic could be wrong here. So while not digital read button pin. Okay. Oh yeah, so we want to change this to get rid of the not. And so while this registers as true, it will keep doing this. And so because our button reads a 1 here all the time, that's true. And so when it's not pressed, it registers at true. So this will keep sticking here until it registers false, which is when we press that button, it goes down to 0. So let's try it again. So our light goes on, it goes off, and you can see we're stuck here. I press the button, it registers that button press, and it does it again. Okay, and so this is a really good spot to be in. We've got basically the light's going to turn on, it's going to turn off, we press the button, and then we register that button press. And now we're going to actually turn this into a game. So the next step is, well, I'd like to know how long it took me to press that button. And so we're going to make another variable to track our time. So we're going to say int, actually, what we'll do is we'll make a local variable here. We're going to say unsigned long start time. Okay, so we're making a variable called an unsigned long, and this is a type that holds like a really big integer. And we're going to set it equal to this function called millis. And millis is a function that basically looks at how long the device has been running for, how many milliseconds, and it stores it in that variable. And so start time stores the time the device started, stores the time the device has been running for. And it doesn't count forever, so eventually it like kind of wraps around, starts back over at 0 when it gets too big. But this tells us when it started, and then after we press the button, we want to do it again. And so now we'll call this the end time. And so now we have a variable called the start time and the end time. We make another one long, and this will be our total time. and this is our end time. Just a little bit of math here, right? End time minus start time. Okay, and so what's going on here is the LED turns off, we see what time it is, we wait for the button to press, and then we see what time it is again, and then we're going to take that and subtract those two. So this is the many milliseconds it's been running at that point, and this at that point. If we subtract those, we can actually find out how long it took for us to press the button. And so we'll press this. We'll say serial.print ln print. We'll say it took you, and then we'll add another line here. Serial.print, and then we'll put our total time. And we'll say serial.print seconds to, we'll put a space here as well, press the button. Okay, and then we'll add the ln, and so now we run this game, or run this now, and so the light goes on, we press the button, it says 550 milliseconds, 381. Oh, I cheated there. It didn't register that time. That was 3 seconds. And so you can see it's telling me how many milliseconds since the light went off until I pressed the button. Okay. And so here it's locked up waiting. And so this is pretty good, right? So the light turns on, we press the button, and then it times how fast we did it. So let's make this delay a little bit longer. So we have more time in between. Let's say 5 seconds. Okay. And then what would be really good is if it was less predictable. So let's say that it waits at least 2 seconds, but let's also add a random component so that it waits a different amount of time each time, so that it's actually measuring our reaction and not measuring our ability to follow the pattern. Okay, so what we're going to do is we're going to generate a random number. Before we do so, we're going to add this line right here. In our void setup, we're going to say random seed analog read A0. There's a lot here that we don't know yet, but basically when this device generates a random number, it can't actually generate a random number. It's not capable of it. What it does is it's got some kind of table in there or some kind of algorithm it's going to use, and it's going to calculate a random number based on that table. It's kind of like looking it up in the table essentially. And based on where you start looking up in the table, you're going to get the same sequence of random numbers every time. Okay? And so what this does right here is it's reading the voltage on pin A0, and we'll learn about analog inputs later. And it's using that to pick our starting place in that lookup table. Now, maybe not exactly what's going on here, but it's a good kind of way to think about it. So we're picking the spot in that lookup table, and so this kind of gives us a random starting point. Not fully random, but somewhat random starting point, so that we don't get the same sequence of numbers every time. Okay? And so now, what we're going to do is after this delay, we're going to have additional delay, and we're going to say random. No. Yes, we're going to say random, and we're going to put a number here between. Basically, it gives us that we can set a range. So we want it to be between 1,000 and 3,000. Okay? So what will happen here is that it's going to wait 2 seconds plus some amount here that's somewhere between 1,000 and 3,000. So anywhere between 3 to 5 seconds. So this is going to say wait 3 to 5 seconds, and then we turn the LED off. All right, and so what this does is it's going to turn the LED on, wait 3 to 5 seconds, turn it off, and then it's going to see what the current time is. It's going to wait till you press the button, then it's going to see the end time. It's going to measure the total time and print it out on the screen for us. Okay. or it's going to calculate the time by subtracting those. Okay, and then we got it 5 seconds before it starts again. So we'll run our game. Light comes on, turned off. We press the button. Didn't register. There we go. Okay, so we did 4 seconds. Not great. Let's try again. Light goes on, goes off. We press our button. Got 613 milliseconds. Okay, so this is kind of a fun game. You can try it out on yours, see how you do, see what your best reaction time is. And then we'll do one more thing here to make it a little bit more exciting. Okay, so we've got a reaction time game. It's pretty fun. Get your reaction time, tell you how fast you pressed it. Maybe you don't think it's that fun, but what we're going to do from here is we're going to make it a 2-player game. And so we're going to add basically another button to our circuit. Okay, so we want to come over to here. We're going to get another button. And then we're going to connect, let's say pin 6, and then the other end to ground. Nope, let's keep that as yellow. All right, now we could do the other end to ground. Okay, so now we have our 2 buttons, and we can make it a 2-player game. Okay, so we can see who's faster, us or our neighbor. Okay, and so now let's modify our game to work with these 2 buttons. And so we'll call this button pin 1. And this button pin 2. And button pin 2 is on pin 6. Okay, we'll set that one as an input as well. Okay, so button pin 1 and 2 are inputs. And so now we modify our game to take those 2 inputs. And so what we're going to do here is something we haven't learned about yet, but we're going to make another function. And so we're going to say int check buttons okay, and then we're just going to read both buttons, and we'll say digital read, say int player 1 equals digital read button pin 1. We'll do the same thing for player 2. And we'll call this button pin 2. Okay. And then we'll say if player 1 equals 0. And then we're going to type here return 1. And what that does is it's going to send, we're going to call this function, and this is the value we get back if player 1 had pressed the button. We'll say else if player 2 equals 0. We're going to return 2. Okay. And then we're going to say else we'll return 0. Okay. And so this function here is a block of code that checks the 2 buttons, and it's going to return 1 if it's player 1 that pressed the button, returns 2 if player 2 pressed the button, returns 0 if no button is pressed yet. Okay, and then yeah. So here in our while loop, we're going to change it. We're going to add the brackets. Okay, and we're going to make a variable called winner, and we're going to set it equal to 0, and then we'll say while winner, and then double equals 0. And so this means as long as that variable is still 0, we're going to keep looping. And we're going to say winner equals check buttons. And so it's going to basically do what's called polling, or read these buttons over and over again until one is pressed. Now there are better ways to do this, but again, for now, this is going to be the way that we approach it. And here in this code block, it's checking the two buttons, checking to see if either of them is equal to 0 or returning 0. Okay, and then the last thing here is we just want to print out the person that won. And so we got button pressed. We're going to say player, and then we'll print the winner. And then we'll print another line here. And we'll say wins. We'll add the L in here so it skips a line. Okay. And we'll get rid of the U since there's two players. Okay, so we start our simulation here. And so we press the button. And this time player 1 wins because they pressed it first. Now we'll try again. This time player 2 will win. There you go, player 2 wins. And so let's go ahead and modify this here to add a space. So we get a space between the winning message, or the number, and then the word wins. Okay, and now we've built a kind of reaction time game. So once you have this built, you should try playing it with your neighbor, so you've got a faster reaction time. And then from here, we can look at modifying this game, tweaking it, doing more with it during our finals period.